Okay, so for this example here, what's going on is you have some point. So again, this is part two. Part two for section 7.4, okay? So again, what's happening is you have all these points that are on the original function, and on the right side, you're going to match it with the corresponding reciprocal, corresponding point in the reciprocal function. So 7 comma 1, again, the x value stays the same, and the y value is reciprocal, so 1 it just becomes 1. So the first one's going to be f, okay? The second one is 0 comma 4, again, the x value stays the same, and the y value becomes 1 over 4, and that's like b, okay? C, you have like x is negative 1, but the y value is 0, so you can't take the reciprocal of 0. So therefore, hey, number 3 is g, it's undefined, okay? The fourth one is actually a trick question because none of the choices actually work. X value stays the same, and the y value, see it's negative 1, it stays negative 1. So none of the above, okay? So I threw that in there. Last one's negative 3 comma negative 5. So again, x value stays negative 3, but the y value, you see how it's negative 5. The reciprocal will be negative 1/5. So you will have like negative like 0.2. So that would be j, okay? Okay, move on. So match each graph with on top with a corresponding reciprocal function. If you look at the first one, again, you gotta find your asymptote. Okay, and you notice how the graph goes down. So reciprocal comes out, hits a common point, and then plateaus to the right. Left side, the graph is going up above. It's positive, so the reciprocal is always going to be positive, also going to be positive, and it goes down like that. Okay, so the first one looks like it's going to be C. Okay, so C is right there. Second one, this is the line where all the y values are going to be 4. Okay, so no matter what you pick the point, the y value is always 4. So the reciprocal of 4 is 1/4, right? So the reciprocal of 4 becomes 1 over 4. So that means if you were to get the reciprocal graph, it'll be everything in the bottom over here. So y equals to 1/4. So the second one is A. Okay. Third one, okay, you look at the asymptote still on the left side, and again the right side is positive, so therefore the reciprocal will also be above the x-axis. Left side's going down, negative, so the reciprocal comes up, also negative, hits a common point and goes to the left. So that one looks like it's B. Okay, so CAB. Okay, so this was an additional example. I threw it in there. It's not. I didn't teach this one in class. So this one here is okay. Here's my original function: y equals f of x. And then on the right side, which one of them is the correct reciprocal graph? Okay. So what I would do then is, all right, let's look at this graph here. First step, you have your asymptote right over here, right? So therefore, you start with the asymptote. So if you look at all the choices, it can't be B, it can't be D, so it's either A or C, okay? Next thing is, let's find your common points. So common point is, so what I did was, I just took some points. Okay, let's say here's like the first point. This point here is like, I don't care about the x value, I only care about the y value. Y value is 0.25. So that means there'll be same x value, but the y value is going to be 4 right up here. Okay? Pick another point, x2, where the y value is half. So that's this point over here. Okay, y value is half. So reciprocal of that becomes 2. So same x value goes up 2. Then next is 1. So 1 is funny because the x comma 3, 1. Y value is 1, so therefore that's a common point. Okay. Then what you can do next is just pick some points. That one has a y value 2. The reciprocal becomes half. And then next one, y value is 4, so reciprocal becomes 0.25. So you connect the dots, graph looks like this. Okay? So the only one that looks like that is A. Okay, so the answer for this one's A. Okay, so on this slide here, now you can look at, hey, what are the steps in graphing the reciprocal of a quadratic function now? Okay? Not a linear anymore. So a quadratic function has, the word I'm missing here is up to 2 x-intercepts, because it can have 0, 1, or 2, okay? And if you have 2 x-intercepts, each of the x-intercepts will become a vertical asymptote, okay? So if you have 2 x-intercepts, that means you're going to cut the graph into 3 parts, okay? So it'll look something like this. So let's say you have a parabola here, there are 2 x-intercepts. So now you have 3 parts, left, middle, and right, okay? And if you have only one x-intercept, that means you cut into 2 parts. So after you graph the asymptotes with the x-intercepts, next thing you do is you get to count the number of common points. It's where the y value is either 1 or -1, okay? So you look at the graph here, hey, this is where the y value is 1, so you have 2 common points, okay? 2 on the top. And then you also have 2 on the bottom like this, okay, where the y value is -1. And if the graph is opening upside down, you can also have 2 at the top and then 2 on the bottom, okay? Again, these are points where the y value is either 1 or y value is -1, okay? So in general, you have up to 4 common points, okay? So in general is, hey, you will have 3 parts when drawing the reciprocal, left, middle, right. And so you always draw them starting from the asymptote, okay? So you start from the green line, okay? And in general, if the points on the parabola are near the x-axis, the reciprocal will be far. And if the points are far from the x-axis, then the reciprocal will be near, okay? And again, remember, it's respect to the x-axis, okay? So what you end up getting is, you see how the left side here is going like really close to x-axis, and it's going up, it's getting further away from the x-axis. That means reciprocal is going to come from the top, where it's really far, and it comes down, okay? And it plateaus all the way towards the x-axis. Same thing on the right, graph goes up, so reciprocal comes down. And in the middle, the only point that you got to care about is the vertex. So whatever the vertex is, okay, let's say the vertex right here is 9. The reciprocal of 9 or -9, right? So the reciprocal becomes -1, 9. So what that means is the reciprocal graph will come from -infinity, goes all the way up, and it hits that point over there, and then it goes back down. Okay? So when you're graphing the reciprocal of a parabola, make sure you consider where the vertex is. Okay? Because that's going to be the point where the graph hits the reciprocal of the vertex. Okay, so here we go. This example here is, you're given a parabola in the bottom, and you're asked to graph the reciprocal of this parabola, okay? So first step again, graph the parabola. So this is the easy one. The vertex is over here at -4. The x values are -2 and 2, okay? So if you're looking for the x intercepts and you don't know how to find it on the graph, just do it algebraically. You make y equals 0, and then you solve for x. So you move the 4 over, and then you square both sides. You get x equals 2 plus or minus 2. Okay? So this one is x cannot be 2, and the other one is x cannot be -2. Okay? Okay, next thing, find your common points. If you're looking for your common points, it's where the y value is 1 or -1. And if you look at this graph, you know there's going to be 4. Okay? So what I would do is, you take this original equation in the bottom. Okay, this is the parabola equation, okay? And you make y equal to 1. Okay, so you see how this is 1? And I'm going to solve this algebraically. Okay, so you move the 4 over, you square root it, you get plus or minus 5. So what that means is, the common points will be x is -5, and the y value is going to be 1. And then x could be +5, and the y value is also 1. And you know it's 1 over here is because you made y equal to 1 over there in that equation. And you do the same thing with -1, so you make y equal to -1, and now you solve for x. You move the 4 over, so you get 3. Square root them, you get plus or minus root 3. So therefore, the second one, your common points will be, hey, -3 comma -1, and +3 comma -1. And they're both -1 because you made the y value equal to -1 there. Okay? So you can estimate what it is. So those are the 4 common points. Okay? After this now, all you gotta do is pick some points on the red graph, and you take the reciprocal of those y values. Okay? So again, this point over here on the graph, really close to the x-axis, that means the reciprocal is going to be really, really far. So somewhere on the top. Okay? Or something like that. And then I pick a point that's really far from the x-axis, so the reciprocal will become much closer. And then there's my graph. Okay? So it probably goes up, reciprocal comes down. Okay? Same thing on the left side. You know it's a mirror image, right? Okay, it's a reflection, symmetrical. Okay, so for the middle, so this point over here is -4, so the reciprocal will be -1/4. Okay, so that's going to be -1/4. And then again, you pick some points, you get a reciprocal of them. There's my graph then. Okay. So what you get up now is this blue graph is this equation, like for that equation. Okay. So domain will be x can be all real numbers except where the two asymptotes are, and the range is where things get harder. Okay, so range, you gotta worry about the top part and the bottom part. So for the top part, it'll be y is bigger than 0, because the graph will come from top infinity and come all the way down towards the x-axis but never touching it. And then for the bottom part, okay, now this value here, negative 0.25, comes from the reciprocal of the vertex. Okay, so when you get in the range, the vertex is actually quite important. Okay, so the graph comes all the way up, hits the common point, hits a couple points that you have, and then hits the reciprocal of the vertex, and it comes back down. And so remember, it's less than or equal to negative 0.25. Alright, move on. Okay, so for this one, you're asked to get the reciprocal of each of these graphs. Okay, so the first one, you only have one x-intercept. So therefore, you will have one vertical asymptote. And the next thing with this is you have two common points, one over here on the left and one on the right. Okay, so one left, one right. And the third step is, hey, the graph goes up, 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 up like this on the left side. Okay, that means the reciprocal is going to come down like this. Okay, so come down, 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 down like that. Okay, and the parabola is going to continue going up. So therefore, the reciprocal is going to continue plateauing towards the x-axis. Okay. Second one, there's no x-intercepts. Okay, so you can't do anything with x-intercepts. No vertical asymptotes. Number two, only one common point. Okay, which is over here. And so the second one is what we call the heartbeat graph, because this graph will look something like this. Everything is really close to the x-axis, coming towards the reciprocal vertex. So it'll be like, and then when you over here, you go beep, and then you go back beep. Okay, so there's my graph. Okay, it's kind of, anyways, there it is. Okay, I guess let's move on. Summary-wise, you can look at it yourself on the PowerPoint, and I'm going to, let's see, jump to this one. Okay, so match each parabola with a corresponding reciprocal function. First one, okay, again, parabola is above the x-axis. There is no vertical asymptote, and there's no common point because it starts at 2. So therefore, this one will look something like this. Heartbeat graph again, go all the way to the vertex, go beep, and then go back down again. Okay, and that one is actually going to be B. Second one, graph is upside down. You have two x-intercepts. Each one becomes an asymptote, like that. Okay, so again, left side goes like this. This is negative. Right side goes like that, and the middle comes all the way down, hits the common point, and goes back down. Or goes back up. That one's going to be C. And then the third one, one x-intercept, so therefore one vertical asymptote. And then, yeah, something like this. Okay. Alright, so this one will be D. Okay, last one. Okay, let's see how much time I have left. Okay, last one. Okay, this is the main one. Okay, if you can do this one, that means you actually know your stuff. So you're asked to find the domain and range of the reciprocal function for each one of these, okay? So before I do them, I'm just going to draw the graphs out because it helps a lot. So again, the first one is, you look at the bottom, you know it's going to be a line. And the line's going to be like 1, 2, 3, 4, y-intercept is 4, and the slope is 3. So it looks something like this. Okay, here's my line, y equals to 3x minus 4. So if you're looking for the domain and range, number one, you're going to find the asymptote. Okay, so if you do the math, you have like 0 equals to 3x minus 4. So 4 over 3 equals x. Okay, so this is like x equals 2, cannot be 4 over 3. So your domain right away would just be x can be all real numbers, except x cannot be, sorry, my bad. X cannot be 4 over 3. Okay, and then the graph will look something like this, look something like that on the other side. So the range would just be y can be all real numbers, except y cannot be 0. Okay. Second one we did already. Second one is where you have a parabola. Again, the second one's like a parabola. Okay, parabola's gonna be 4 units down. 1, 2, 3, 4, all the way down like this. Okay, and the second one you will have your two asymptotes, right over here at 2 and negative 2. Okay, so again, you know your domain is gonna be x can be all real numbers, except x cannot be plus or minus 2. Right. And then, because the bottom part, this is negative 4, I mean reciprocal will be like negative 1 over 4. This part goes like that, right side goes like this, and then the middle is going to be a U shape towards the negative 1/4 and goes back down. So again, range is y is bigger than 0, and then y is less than or equal to negative 1/4. Okay. The third one is a parabola, but the whole entire parabola is above the x-axis, so it'll be like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so parabola goes up like this. Okay, therefore this one, the reciprocal, will be a heartbeat graph, so it'll go up and then go back down. So since this is positive 9, reciprocal, this is like negative 1/9. Okay, so again, domain, there's no vertical asymptote, so x can be all real numbers. Okay, and for the range, so since everything is between bigger than 0 and less than 1/9, so y is bigger than 0 but less than or equal to negative 1/9. This is the key one. Okay, make sure you understand what's going on here. Okay, because the red graph cannot go above 1/9, but it intersects it, and it can't go past 0, so it must be bigger than 0. Okay, last one. This one here is a parabola, and it's shifted 3 units to the right, so 1, 2, 3. So a graph looks something like this. Okay, so therefore the reciprocal graph will be like a 1 asymptote, right side, left side. So domain is x can be all real numbers except x cannot be 3, and then the range is y must be bigger than 0. Okay, I think my time is up and we are done.